Good morning. Today we are going to start looking at section 6.6. We are working on graphing radical functions, and the target for this section is to graph square root and cube root functions. Today we're going to focus on the square root graphs. So in our chart here, we talk about our parent function for a square root, okay, just y is the square root of x. And then we can do all of those same transformations that we've been talking about all year. If we put a negative in front of it, now we are looking at reflecting over the x-axis. If we put a number in front of that square root symbol, depending on the number, it's either a stretch or a shrink. So anything bigger than 1 is going to stretch it. Any number between 0 and 1, like a half, is going to shrink it. And then our h and k, remember, is our left-right shift and our up and down shift. And the same thing is true for all radical equations, but we're going to focus on the square root ones today. So our parent function, if you think of making a table of values, for a square root, remember we can't square root negatives, so the smallest number I could plug into my function here would be a 0. And the square root of 0 is just 0. So we do have 1 point at 0, 0. Then I could plug a 1 in. The square root of 1 is just 1. The next number that makes sense to plug in would be a 4 because it's easy to square root. I just get a 2. My next perfect square would be a 9. When I square root it, I get a 3. Okay? So our square root graph has this endpoint here at the origin, and then it curves off to the right. So to graph a transformation of that, we start with just our basic square root function, our table of values. So this is y equals the square root of x, the parent function. And then we look at what kind of transformations we are doing to it. Do we have to stretch or compress it? Do we have to reflect it? We do those things next. And then last, we would deal with any left, right, or up, down shifts. So again, we're going to start with our parent function, 0, 0. And I typically make that endpoint large enough that I remember it's the end of my graph. 1, 1, 4, 2, and 9, 3. Okay? And then we look at the transformation. Because this is on the outside of my square root symbol, that minus 2 is not underneath the square root symbol, it is a vertical translation. So this is anything that I'm adding or subtracting outside of that radical symbol. So my transformation here would be that I'm shifting it down 2. So I'm going to take all my values now, and I'm just going to move them down 2. Okay, so my new endpoint would be there. I have that point. Everything's just getting shifted down 2. And then I can draw in my curve. Make sure you have an arrow on the right side, but that it stops at that endpoint. And then remember, domain are your x values, and range are your y values. So in this case, my x values start at 0. All right, and I'm going up, anything higher than 0. Or it could be at 0, so greater than or equal to 0. My y values, I had an endpoint here, so my lowest y value is going to be here at negative 2. And then my curve goes up from that, so y has to be greater than or equal to negative 2. All right, let's try another one. If the thing that we're adding or subtracting is inside my square root symbol, it's underneath that square root symbol, then it's a horizontal translation. So if I see an x plus 4, I'm actually shifting it left 4. So all my x's are going to move 4 to the left so that when I add the 4, I get back to where I was. All right, so we start with plotting our parent function points again. 0, 0, 1, 1, 4, 2, and 9, 3. Okay? And now we're going to shift everything 4 to the left. So this is my new endpoint there. My graph is going to curve like this off to the right side. And then domain, my x's now, because I've shifted everything 4 to the left, the very first x value that I use is here at -4. So y has to be greater than or equal to -4. My range, the lowest y value that I use is here at 0, and then everything goes up from there, so greater than or equal to 0. All right, let's combine some of those transformations. So we have several things happening in this one. The very first thing I see is this 3. Because it's a positive 3, I have not done any kind of reflection. And that 3 is going to cause me to do a vertical stretch by a factor of 3. So everything is going to get tripled in terms of its vertical height. Okay. Then I see this +2, so my next shift is that I'm moving left 2. And the last thing I see is the -4, so I'm going down 4. Okay? So we're going to take our parent function points, and let's think about what would happen. We'll go ahead and plot them quick. 0, 0, 1, 1, 4, 2, and 9, 3. We're going to stretch them vertically. That means my y value, which was the square root of x for my parent function, now becomes 3 square root of x. Okay, I have to triple all my y values. So this 0 times 3 is still 0. 1 times 3 becomes 3. 2 times 3 becomes 6. And 3 times 3 becomes 9. Those are my new y values. So let's go ahead and plot those. So 0, 0. The 1 turns into a 3. The y of 2 turns into a 6. And the 3 turns into a 9. So you can see that I've done kind of a stretch vertically. Everything's getting taller. And then I have to shift all my points left 2 and down 4. Okay, so let's start with our endpoint here. Left 2 and down 4 puts me right there. My next point, left 2 and down 4, lands here. This point, if I go left 2 and down 4, lands here. And left 2, down 4, lands here. So this is my new stretched graph. So it's much steeper than the previous original function. And we've shifted it left and down. Okay, so again, my endpoint here is going to determine my domain and range. The lowest x value that I have is here at -2. So x has to be greater than or equal to -2. And the lowest y value I have is here at -4. So my y values would be greater than or equal to -4. So your domain and range are going to be based on that endpoint of our curve. All right, let's look at one more. This one has a negative in front, which means we have done a reflection. That negative sign is going to cause a reflection over the x-axis. The 1/2 my board's off a little bit here. The 1/2 is going to cause a vertical shrink by a factor of 1/2. All my y values are going to be cut in half. Then I have a -3. So x minus 3, I'm actually going to shift it right 3. Remember, it's always x minus h. In this case, h is 3. And the last thing then is the +1, which means I'm going up 1. So I've identified my transformations. I'm going to go ahead and plot my original points, 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so we're going to reflect them over the x-axis. So it's going to turn them into this, down 1, down 2, and down 3 instead. Okay, so my curve has now been flipped upside down. We then want to shrink all of our y values to half of their original size. Okay, half of 0 is still 0. Half of -1 would be -1/2. So this stayed at 0. This became -1/2. Our -2, half of that would be -1. And our -3, half of that would be -1.5. Okay? And now we have to shift everything right 3 and up 2. So we're going to take these green dots and move them right 3 and up 2. This is now my new endpoint. Right 3 and up 2. Now remember, we're in the half mark. Okay. My next green dot, right 3 and up 2. And next one, right 3 and up 2. So I have this kind of compressed upside down square root graph. Okay. Now, remember, our domain and range come from this endpoint. So think about where it is on the x-axis. This one's hitting at 3. So my domain is that x has to be greater than or equal to 3. All my purple part of my graph here is to the right of 3. For the y values, though, notice that our curve is going down from this endpoint. So this 2 here is actually the highest my graph is ever going to get. So my y values are all going to be less than or equal to 2. I'm sorry, I shifted everything up 2, and I was supposed to shift everything up 1. I just noticed that. All right, let's try that again here. Let's take our green dots and shift them right 3 up 1. There's my new endpoint. Right 3 and up 1. Okay, right 3 and up 1, and right 3 and up 1. All right, there we go. Okay, so domain still is x greater than or equal to 3, but my range y should be less than or equal to a 1. That's the highest I get there. All right. So our focus today again is on graphing square root graphs. We start with our parent function, and then we look at any kind of transformations. To move that parent function. So we have y equals a times the square root of x minus h plus k. This is our up and down. Our h value here is left and right kind of shifts. Our a value, if it is negative, it means reflecting over x. If it is bigger than 1, it means a stretch. And if it is between 0 and 1, it is a shrink. All right. And then again, domain comes from your endpoint. Okay, let me know if you have any questions.